Hello everyone, this is our second lecture of CS 224 and here are the today's goals. I'm planning to make it, there's a typo as you can see. Alright, so today's goals are explaining parts of greenSheet, what are the types of instructions and the difference between data and text memory segmentation location Mips. Um, let's start with explaining parts of greenSheet. So as you see here, I have my greenSheet here, and the parts that I'm going to explain today is going to be the core instruction set, which is, I'm not going to explain all of this part right now, but I'm just going to give an example on how to use it, like relating to Mips program Mars, how to use it. I'm going to explain how to use it related to Mars. And I'm going to be using this table again one more time. And finally, I'm gonna talk about memory allocation because as you can see here, difference between data and text memory allocation maps. And the text in here and data is here and they're allocated in maps. So let's start with Mars. Before I start with Mars, I want to make sure that to explain the core instruction set and why is it very important. So basically, each instruction has a name, mnemonic, format, operation, and opcode and function. I'm not gonna explain this today. I'm gonna leave this for future. I think maybe third or fourth class, not sure yet. All right, let's go back. So first of all, we have the name of instruction. Let's say, for example, this one. This one is add. And the mnemonic of it is what you write inside the Mips program. Let me give you an example. Alright, as you can see here, I open the program. And as soon as we start, remember, we write .data and .text. In the data, uh, we have strings. We store strings and arrays, and in the text part, we store code, as you remember. Now, another thing in data we can store numbers, and here is how to store numbers. First of all, initialize a name. I'm gonna call it number one. Num1 stands for number one, equal to, or like two dots, and then dot word, because as you can see, store the listed values as 32-bit words on a word boundary. So basically, the words you're gonna store here are gonna be count as integers, and they are like 32 bits. So yep, this is how to store a word in a memory. Now the data part is a memory. Like when you store stuff in data, it's a memory. So now I have number one and I have number two dot word, and this is gonna be 10. You might be wondering, why am I doing this? I'm just like teaching you how to write these in memory, like how to add 5 to memory, how to add a number 10 to memory, and that's this is how to do it. Okay, now let's go back to the sheet, to the mnemonic part of the green sheet, and as you can see, we have add here. So basically all I'm gonna do is I'm gonna write in the text part add, and now we have an add in instructions with the suggestion on how to, like, which one do you want to choose. For example, I want to choose this one, and then how are you going to write it is the key answer. Like how you're going to write it, here are the keys, how am I going to write it. And let's go back here, and as you can see in this suggestion is literally it looks like the operation part in Mips, as you can in the data in the green sheet, and this is literally the same part. Like look, the mnemonic is add and the part of it is literally the same. How? Let me write the code and come back to you. Okay, as you can see here, I have the add instruction written here, and I have the code in this place. I hope it's like it looks fine, it looks normal. And basically, as I said earlier, this is how to add words in how to add numbers in a memory. It's just for practice. You might not be needing it. Uh, and here is how to write an add instruction. So basically, what did we do? First of all, we wrote the mnemonic, and here is the mnemonic, and then we wrote the operation. So RD is, okay, let me write it in a better way. RD is T0, T1 is RS, and T2 is RT. What does this do? It says you're gonna add, it's literally like T0 is equal to T1 plus T2. And this is not what I came up with, it's literally wrote in the operation part. Registers 2 and register 3, add them together and put them in register 1, which is T0. Okay, this is how to use an operation. You look at the mnemonic and you look at the operation and you write it as the way it was written, literally the way it was written. And This finishes it. Now let's go back to Mars and let's let's assign let's assign T1 to 5. Let's assign 5 to T1 and let's assign T2 to 10. Let's assign 10 to T2. Yes, cool. I think you understood what I mean. So basically all you're gonna do is load word, because these are words, right? You're gonna load word, not the address. Load word, and then I wanna when I write load word, they're gonna give me suggestion, and I wanna this suggestion which is T1 and label, because number one is known as variable, or okay, it's not known as variable, it's known as label. From now on, anything that is written in this way, let's say for example num3 and that two upper points, this is literally called label. It's not a variable anymore. All right, cool. So basically, we're gonna store T1 to 5, and this means T1 is equal to 5. We're gonna do the same thing, load word, but to T2, and this now equals to 10. Oh, no, sorry, it's not 5. It is number 1. My bad. I'm so sorry about this mistake. And this is number 2. Cool. And then we have T2 here equal to 10. So basically, when I run the program, all what's going to happen is T2, which is already 10 right now, is going to be plus with T1, which is 5, and T0 will be 15. And if we do this, if we run the program, as you can see here, let me take a screen. Okay, I think as you can see here, T0 is equal to F, which is 15, T1 is equal to 5, and T2 is equal to A. And as you can see, A here is equal to 10, because A is 10 in like 10 is A in hexadecimal, and therefore 10 plus 5 is gonna give us F, and F is equal to 15. Now let's go to format. What is the format? Format is the type of instructions. As I said earlier, we're going to learn the type of instructions. And yep, we have three type of instructions, and they are, oops, not this one, not this one. Where was the pencil? Yeah, this one. There are regular, immediate, and jump. And basically, if we go here, we're gonna see that the format is known with three is already like written with three ways: either R, either I, either jump, or J, sorry, which is J, yes, which is, you can say jump, literally jump, right? And the difference between R and I and J is very vast, and it's very easy to notice. So basically, let's say add immediate. R stands for regular, I stands for immediate, and J stands for jump. So what does add immediate do is it takes not three registers like R does, it takes two registers, and sometimes it takes one register. It depends on the operation, right? On the operation of the name of the mnemonic of the instruction that you choose. So basically, in add immediate, we don't need to have three registers as you can see here. No, we can just have two registers, and R here is a register, R here is a register, and then we have here sign extend immediate, and this is basically numbers that you can just add. So basically, let's do the same example. So we have here add T0 equal to T1, T2. I can do the same thing as well, writing add I, and this means addition immediate with overflow. I'm gonna write T0. Oh, that's a mistake, my bad. Okay, cool. T0, T1, and then instead of T2, I'm gonna see what's inside T2. It's gonna be number 2, which is 10, and then I'm gonna write 10. And it's literally the same. Like, this is literally equal to, I'm gonna write it in a comment, so it's literally equal to add I 10 is equal to add I. How? Because 10 is basically, we know that T2 contains 10 right now, right? Load word T2 in 10, T2 equal 10. So basically I just changed T2 and wrote 10. And that's an immediate instruction where you use stuff that's immediate for you, like it exists there for you immediately. So you don't like waste your time. Should I use this register or not? And this is immediate type of instruction. Well, basically RT sign extension is literally here, RT right? And 10 here is the sign extension part, sign extension immediate, it's literally 10 here. And for jump or like J part, you need to have another label. And this might sound weird, but I'm just gonna add the label here. I'm gonna call it main. And this means this is my main function. Yeah, remember we said these stuff are not variables anymore, they're called labels. And the way of writing it is just to shift everything after it. So text here, main here, and the code is here. And basically jump instruction, let's go to jump instruction right now. And I'm gonna take all of this and delete it to just be clear. Oh, sorry. Go here and jump. And it says here, jump. The mnemonic is J, so all I'm gonna do is write J, right? And it says jump, and there are many types of jump, jump and link register, jump precision unconditionally. I'm just gonna take the basic one. And it says here jump unconditionally, which means jump to statement at target address. Okay, now let's go to this is the type of instruction, which is R, right? We don't care about this. We said right now we see that program counter is equal to jump address. And what does this mean? Basically, the program counter will go to the place that you want to jump to. So I want to jump to the beginning of the sentence, which is main. So basically, all I'm going to do is literally write jump main. What does this do? As soon as it finishes executing this line of code and it goes here to this instruction, it's gonna jump, like it's gonna jump back to main. And this is literally what does it do? It says it means go back to main. Let's say I have another label and it's called mm, main2. And let's say I'm just gonna have add I t0 t0 1, and this means it's gonna be t0 is gonna equal to t0 plus 1, which is literally like t0 plus plus in any normal language, right? But no, we don't do this here. Just make sure that the sorry the the comments are matching, like they should be matching because easy to read for sure. Okay, now I'm gonna leave this right now. I'm gonna go back to it later, but like right now let me just go here. So basically let's run the program step by step. Okay, load word t1 number 1. So t1 now is gonna be 5, which is this part is gonna be 5. Boom, it's 5. t2 is 10, and t0 is gonna be f. If we do the same here as we said, it's gonna be f. Okay, when I say jump main, we are like in line 15 right now, right? In the execute part, we are in line. It doesn't give us the, oh yeah, it gives us the line 15. So the next part should go back from here to this label because jump main, which is boom, we start again. And this is literally gonna be a infinity loop because as soon as we reach line 15, we start the following steps again, so it won't end. So I close the program now, and now I'm just gonna delete this part. Oh no, I'm not gonna delete this part. I'm gonna jump main2, and this means jump to main2. Where is main2? Main2 is here. Oh, sorry. Main. Yeah, okay. Main2 is here. So main. Okay, main. Okay, cool. It looks weird to me. That's why I was like wondering, is this how to write it? Main2. And this basically is gonna jump from line 15 to line 21. Let's do the following. 1, 2, 3, 4, 5. And now where is the PC? Yeah, the PC counter here is at, this is the PC, right? It's at 004000018, and it's literally, oh, it's literally the same as the address here. Sorry, I was looking at the code. It's literally the same as the address here. And now PC counter will not be, as you can see, if we start from the beginning, every time the address is incremented after any instruction, the address is incremented by 4 bytes, and this is how the program works. As soon as you finish one line of a code, the next line is gonna be PC plus 4, which is the address, right? So here the address is 18, right? So the next part, which like if we have a code here, this one should be, let's say, add t0, t1, t3, for example. It doesn't, like this code is useless just for execution. Now we execute it. As you can see, after the jump, it becomes like here we are having jump main, right? And the PC counter here is 1C, which means it's the next line. It doesn't matter even if your line is here, like the execute part is gonna not change because we don't look at the 9 lines between the codes. We look at the codes. Like we don't look at the lines between the codes. We look at the codes exactly. So here is 0, here is 4, here is 8, here is C, and here is 10, here is 1, here is 14. As you can see, 0, 4, 8, C, 10, 14, 18, 1C. If I delete this part and go back here, oops, sorry, go back here, execute it. As you can see, 1C now becomes this place. So this place becomes 1C. When I execute the program, cool. Okay, now it says here jump main 2. So basically we'll go to jump main 2 and it will jump to this part and it will fetch the first code it sees, which is add I. So basically it will just boom, PC counter changed from 18 to 1C. And therefore we know that we jumped. We know that we jumped. How we know that we jumped? Let me give an example. So we know here that T0 is equal to, okay, T0 is equal to 30. Let me, okay, we know, never mind. We know that T0 here is equal to 30, to 15, my bad, 15. So let's say add I T0, T0, uh, T0. So basically this means 15 plus 15 equals 30, right? But here I have the answer as 16, which is like equal 16, because you know we already have the answer here as 5. T0 equal 15. Yep, T0 equal 15. Let me run the program again one more time. Oh my bad, it's add I because it's immediate. It was looking for something immediate, but no, now it's not gonna have any problems. Okay, let's go here, which is line 30. And in order to do this, basically you can just put an arrow here, put a check here and just run the program. It will stop here and then you can continue debugging. Okay, now we have our T0 as F, which is 15, right? We have this part and this line is before main 2 and main 2 is in line 22. This part is in 18. So this part won't be executed. We will jump from here to here. As you can see, boom, boom. Yep, T0 now is still 15, nothing happened. As soon as I press this button, it's gonna become 16. Oh. Oh yeah, it's 16, my bad, my bad. It's because it's hexadecimal, you know. And 16 in hexadecimal is actually 10. So yes, it works. Everything is fine, everything works. Now we are done with explaining parts of greenSheet and types of instruction. We still have difference between data and text memory allocation in Mips, and here we go. Okay, now we're back. Let me explain everything and enough with coding. So basically, we have our memory allocation and we have static data and we have text. Let me take a pause and... Okay, back. Now we have, as we said earlier, we have static data and we have text. Our text start in a memory a piece. Okay, program counter starts from 04000 and it's literally the same. As you can see in text segment, it's literally the same. How do I know this? Let me show you. Look, I didn't bring up stuff from myself. As you can see here, the address starts from 0040000 and it's literally the same 0040000. The addresses of data segment are also the same, so all I just did is to take pictures and to be able to explain it to you. So basically we have text segment and we have data segment, and as you can see the data starts from 100. Okay, here is a mistake here, unfortunately. In the program it starts from 100110000, and in the text it starts from 0040000. And every time we finish a line of code or like an instruction, we go plus 4 bytes, plus 4 bytes, plus 4 bytes to each one of these. Like this one is 00, so this one is 0, right? And then we go from here to here, plus 4. And what are these? As you can see, the 5 here is literally the number of words. Basically, let me write, yes, a word is equal to 4 bytes, and each byte equal to 8 bits, which means it's gonna be 32 bits, right? Sorry, a word is, yes, it's 4 bytes. And as you can see, if we take this one, oops, not this one, yeah, please, okay, whatever. Okay, now it's cool. If we take this one, we're gonna see that here is the address of word number one. The address of word number one is 00005, and the address is, no, sorry, this is not the address, my bad. Let me delete everything, start from the beginning. This is the address, right? And because it's the value plus zero means it's gonna stay the same. So this is going to be, sorry, yep, this is going to be in this line. Number one is gonna be in this line. What about number two? Number two is gonna be here in plus 4. Why? Because we go plus 4 bytes every time we store a word. We go plus 4 bytes every time we store a word. Same as text segment, we start from 0, 0, 4, 0, 0, 0, and every time we start with, we add plus 4 in order to go to next. As you can see, plus 4, and all of them are in hexadecimal. I hope I explained everything. That's all for today. Yeah, text segment is here. Text segment is here. Data segment is data here. That's everything for today. Thank you for watching. I hope you have learned and enjoyed. See you soon.